In December 2000, the American marine industry collapsed overnight. Outboard Marine Corporation, the giant behind Evan Root and Johnson, filed for bankruptcy. For decades, OMC had dominated the water with the roar of two-stroke engines. But the Environmental Protection Agency had issued a strict mandate. Outboard emissions had to drop drastically by 2006. The simple, raw power that built American lake culture was suddenly a legal liability. At marinas across the country, mechanics stared at a fractured supply chain. Dealerships panicked as the foundation of their business evaporated. The paradox was brutal. The very sound that defined a Saturday morning on the water had become too environmentally expensive to keep. Watching this wreckage was Mercury Marine, OMC's eternal rival in Fond du Lac, Wisconsin. Mercury stood on the edge of the exact same cliff, selling the same loud, fuel-thirsty black motors. Yet while the biggest outboard giant in the world drowned under the weight of new rules, Mercury survived. But the real story of Mercury Marine is not just how it survived the great outboard shakeout. It is the story of an American engine company that realized to keep its place on the dock, it had to kill the very sound that made it famous. Every week, we tell the stories of American engines, factories, machines, and industrial names that once taught the country what power sounded like and what happened when the market moved on. Subscribe if that history matters to you. The story begins not with nostalgia, but with a specific place in Cedarburg, Wisconsin in 1939. The story begins in the lingering shadows of the Great Depression, in a place that had nothing to do with speed or glamour. In 1939, a young, notoriously demanding engineer named Carl Kiekhaefer purchased a bankrupt manufacturing plant in Cedarburg, Wisconsin. The facility had previously belonged to Cedarburg Manufacturing, a failed company that had tried and failed to build cheap boat engines. Kiekhaefer did not want to build boat engines. His plan was to use the factory floor to manufacture magnetic separators for the Midwestern dairy industry. But when he bought the brick building, it came with inventory. Sitting in the back of the dark, silent factory were 300 defective outboard motors. An outboard motor, a self-contained boat engine, complete with an engine block, a transmission, and a propeller, all mounted together outside the hull of a boat, was not a new concept in 1939. The American market was already thoroughly dominated by the Outboard Marine Corporation, or OMC, the corporate parent of the Evan Root and Johnson brands. Outboards of the 1930s were largely utilitarian machines. They were heavy, loud, difficult to start, and prone to fouling their spark plugs. They were built for fishermen, trappers, and workers who needed to move a wooden rowboat across a lake without rowing. The 300 motors sitting in Kiekhaefer's new factory were called Thor outboards. They had been built for the Montgomery Ward department store catalog, but they were so poorly designed and unreliable that the retailer had rejected the entire batch and shipped them back. Kiekhaefer was a man obsessed with mechanical perfection, and he was completely out of money. He could not afford to scrap the aluminum and iron. Instead, he tore the engines apart. He redesigned the flawed cooling systems, remachined the blocks to tighter tolerances, modified the carburetors, and put them back together. He took the rebuilt engines back to Montgomery Ward. The retailer was so shocked that the engines actually ran reliably that they immediately ordered 500 more. Suddenly, Carl Kiekhaefer was not in the magnetic separator business. He was in the marine engine business. To understand what happened next, you have to understand the fundamental mechanics of the machine Kiekhaefer was building. Almost all outboards of this era were two-stroke engines, a compact power unit that completes its entire power cycle in just 2 piston strokes, firing every single time the piston reaches the top of the cylinder. A two-stroke does not have a separate oil pan or an oil pump like a car engine. Instead, lubricating oil must be mixed directly into the gasoline. This design created a distinct set of industrial and cultural trade-offs. Because they fired twice as often as a standard 4-stroke engine and lacked heavy valve trains, two-strokes were incredibly light and brutally powerful for their size. But because they burned oil on every stroke, they were inherently smoky, loud, and inefficient. They idled roughly. They spit unburned fuel directly into the water. In 1939, nobody cared about the emissions. They only cared about whether the engine would start when the pull cord was yanked. By 1940, Kiefer had realized that building unbranded motors for a mail-order catalog was a trap. He wanted his own brand. At the 1940 New York Motor Boat Show, he introduced a new line of outboard motors with a new name, Mercury, named after the Roman god of speed. The early Mercury engines were a shock to the Marine Service network. While Evinrude and Johnson sold dependable, steady workhorses, the first Mercury blocks featured forged steel connecting rods, aluminum pistons, and a dual rotary valve design that allowed them to rev higher and run smoother than the competition. Kiefer was introducing the concept of high-performance engineering to a market that had previously only expected basic utility. But before the Mercury brand could truly scale, the American consumer market vanished. The outbreak of World War II halted recreational manufacturing across the country. The war, however, became the crucible that forged the modern Mercury engine. Kiefer won military contracts to build two-stroke engines for a very different kind of machine. Two-man portable chainsaws used by combat engineers to clear jungles, and small, high-revving engines for military target drones. Building drone engines and combat chainsaws taught the factory in Cedarburg the absolute limits of air cooling, aluminum casting, and continuous throttle durability. The military demanded engines that could run at maximum RPM until they ran out of fuel, in the worst conditions on Earth, without seizing. When the war ended in 1945, Kiefer returned to the civilian outboard market with a deep understanding of mass production, lightweight metallurgy, and high RPM reliability. And he returned to a country that had fundamentally changed. The post-war economic boom created the American middle class. Millions of returning GIs bought homes in the expanding suburbs. They had cars capable of towing trailers, paved highways that reached into rural areas, and something previous generations rarely had, the weekend. America was ready to go to the lake. The demand for outboard motors exploded, transforming from a niche tool for commercial fishermen into a cornerstone of American family recreation. Dealerships sprang up around the Great Lakes, along the Florida coasts, and near every major reservoir in the Midwest. OMC was ready to sell these new boaters a quiet, reliable motor for a quiet, relaxing weekend. But Carl Kiefer had a different vision of what American power on the water should look like. He did not want to build a quiet engine for a slow rowboat. The outboard motor had been saved from the scrap heap, but to actually challenge the giants of the American lake, Kiefer needed an engine that didn't just run, it had to scream. In the mid-1950s, the American outboard motor market was a fundamentally polite industry. Outboard Marine Corporation was the undisputed giant, selling hundreds of thousands of Evinrude and Johnson motors to American families. Those engines were designed to be quiet, friendly, and painted in soft colors like seafoam green, holiday bronze, or aquamarine. They were built for a leisurely afternoon of fishing or a slow cruise across a glassy Midwestern lake. Carl Kiefer looked at that market and decided to build an engine for people who wanted to dominate the water. To understand Mercury's breakthrough, you have to understand the physical limits of a boat transom. The flat, reinforced surface at the rear of the hull where an outboard motor is clamped or bolted. You can only make an outboard engine so wide before it becomes too heavy, disrupts the wake, and ruins the boat's handling. OMC was building wider V4 engines to incrementally increase power. Kiefer, obsessed with speed and aerodynamics, went vertical. In 1957, Mercury introduced the Mark 75. It was a straight six, a six-cylinder engine arranged in one vertical line, and it was an absolute shock to the marine industry. It produced an unprecedented 60 horsepower. Horsepower, a measurement of how quickly an engine can do work, was no longer just an abstract number on a spec sheet. On an American lake, 60 horsepower meant a boat could easily pull multiple water skiers, rapidly plane out a heavier wooden or early fiberglass hull, and outrun almost anything else leaving the marina. The straight six architecture created a towering, narrow engine block. It looked entirely different from the squat, wide OMC motors. By the 1960s, Mercury pushed the displacement, the total volume swept by the pistons inside the cylinders, even higher, eventually breaching the mythical 100 horsepower barrier. The public gave this engine a nickname that stuck in the American garage for decades: the Tower of Power. These massive two-stroke engines required an immense amount of fuel and air. They were fed by multiple carburetors, devices that mix fuel and air before the mixture enters the engine. A Mercury tower of power often featured three carburetors stacked vertically along the front of the block. For a mechanic in a small-town marine shop, tuning those carburetors so they opened in perfect synchronization was not just a repair job, it was a rhythmic Saturday morning ritual that determined whether the engine would idle smoothly at the dock or scream perfectly at full throttle. But Kieckhofer did not just change the engineering. He changed the psychology of the American boat dock. In the 1950s, outboard motors were painted in two-tone pastels to match the automotive trends of the day. In 1962, Kieckhofer ordered that all Mercury outboards, regardless of size, would be painted exactly one color, phantom black. The decision was brilliant for manufacturing, as it streamlined the paint process and reduced assembly line costs. But culturally, it was a weapon. Black paint made the towering inline-six engines look slimmer, more menacing, and visually distinct from half a mile across the water. You did not have to read the decal to know what was pushing a boat. The black motor became a powerful status symbol. In an American marina, a white Evinrude signaled a family outing. A black Mercury signaled aggressive speed. Speed without reliability, however, is useless, especially on the water. If a car engine fails, you pull over to the shoulder. If a marine engine fails, you are stranded, drifting, and potentially in danger. To prove that his high-revving, highly stressed engines could survive the abuse of the average American boater, Kieckhofer needed a testing ground. In 1957, he secretly purchased an isolated 10,000-acre tract of land in central Florida containing a private 3-mile-long lake. It was known to the company simply as Lake X. Lake X became the most secretive and punishing engine testing facility in the American marine industry. Kieckhofer ran his engines 24 hours a day, 7 days a week, pushing them until connecting rods snapped, aluminum pistons melted, and lower gear units disintegrated. When an engine broke, the engineers tore it apart on site, found the weak point, redesigned the casting, and sent it back out onto the water. To prove Mercury's durability to a skeptical public, Kieckhofer staged a grueling 50,000-mile endurance run at Lake X. Two boats powered by 60 horsepower Mark 75 engines ran continuously for 68 days, stopping only to refuel and change drivers. They completed the 50,000 miles without a single catastrophic engine failure. It was an undeniable proof stack. Mercury was no longer just the loud, fast option. It was the loud, fast engine that would not break. This combination of aggressive marketing, distinct visual identity, and proven durability allowed Mercury to build a fiercely loyal dealership base. A service network, the dealers, mechanics, parts suppliers, and manuals that keep a machine running after purchase, is the true foundation of any engine empire. Mechanics love Mercury because the brand explicitly supported racing. From local hydroplane shootouts on Midwestern rivers to offshore endurance races in the Atlantic, Mercury engines were everywhere, and the factory poured money into the teams that ran them. Winning on Sunday meant selling on Monday, a philosophy Detroit automakers used for cars, but which Mercury perfected for the water. By aligning the engine with racing, Mercury convinced an entire generation of American boaters that they were not just buying an internal combustion engine to turn a propeller. They were buying a high-performance machine. The company had carved out a massive, highly profitable empire based almost entirely on the promise of going faster than the boat next to you. By the time the muscle car era took over the highways, Mercury had already brought that same aggressive, unapologetic power to the American dock. By the 1970s and 1980s, Mercury Marine was no longer just an upstart company in Wisconsin. It had become the dominant mechanical force on American water. The Brunswick Corporation, a massive sporting goods conglomerate, had acquired Mercury in 1961, providing the engineering division with the massive capital needed to build an industrial empire. The heart of that empire was Fond du Lac, Wisconsin, a factory town where thousands of American workers poured molten aluminum, machined cylinder heads, and assembled the power plants that defined the summer. In Fond du Lac, the foundry operated at a staggering scale. Engine blocks were cast, precision machined, and painted in the trademark Phantom Black, then moved down the assembly line where workers mated the power heads to the lower gear units. Mercury was shipping out hundreds of thousands of motors, and the American lake dock became a divided territory. If a boater wanted quiet utility, they bought an Evinrude. But if they wanted to dominate the horizon, they bought the black motor. This era coincided with the explosion of a uniquely American phenomenon, competitive bass fishing. In the reservoirs of the South and the lakes of the Midwest, fishing was transforming from a slow, quiet pastime into a high-speed, high-stakes tournament sport. Fishermen were buying specialized bass boats, low-profile fiberglass hulls designed by companies like Ranger and Triton. These boats did not just need to float. They needed to launch out of the water and race across choppy lakes at 60 or 70 miles per hour to reach the best fishing spots before the competition. To meet this demand, Mercury realized the towering inline six had reached its physical limits. In 1976, they introduced the Black Max. It was a two-stroke V6, a six-cylinder engine with the cylinders arranged in two banks in a V shape, allowing for a much shorter, more compact block that could deliver massive power without throwing off the balance of a small boat. The early Black Max featured a 2.0-liter displacement, meaning the total volume swept by the six pistons was 2 liters, and it produced 175 horsepower, a staggering number for a recreational outboard at the time. The introduction of the V6 fundamentally changed the sound of American waterways. A Mercury V6 at full throttle was a howling, raw, aggressive sound that echoed across the water. It was the sound of gasoline mixing with two-stroke oil, burning rapidly, and exhausting directly out through the propeller hub. At a weekend tournament, the morning launch of 50 bass boats powered by Mercury VD6s sounded less like a fishing trip and more like a drag race. This cultural entrenchment built an impenetrable service network. Across the country, thousands of independent marine repair shops relied on Mercury. A marina that carried the Mercury sign was pledging allegiance to a specific type of customer. They stocked the Quicksilver parts bins, Mercury's official parts and oil brand, and filled their parts counters with the exact gaskets, water pump impellers, and spark plugs needed to keep the high-revving two-strokes alive. A Mercury mechanic knew the exact tuning sequence for the carburetors, the precise torque specs for the lower unit, and the smell of the specific two-stroke oil the factory recommended. In an America where an engine could decide whether a weekend was saved, a tournament was won, or a boat safely returned to the dock before a storm, power was not an abstraction. It was iron, fuel, labor, heat, sound, repair, and trust. Mercury had successfully positioned itself as the undisputed king of performance. The factory in Fond du Lac was running at full capacity, and the brand's identity seemed invincible. The black engine was the undisputed king of the weekend, but the rules of American power were about to be rewritten by a force that did not care about horsepower. By the late 1980s and into the 1990s, Mercury Marine was operating at a scale that defined the economy of Fond du Lac, Wisconsin. The factory was a sprawling industrial complex, a city of manufacturing dedicated entirely to the physics of moving boats faster. Inside the plant, molten aluminum was poured into massive die-casting machines to create the V6 engine blocks. Precision machines carved exact cylinder bores and exhaust ports into the raw metal. The factory floor was a symphony of American manufacturing. The smell of cutting fluid, the roar of engines running in indoor test tanks, and the endless line of phantom black cowlings moving down the assembly conveyor. At this peak, Mercury established a dedicated high-performance division called Mercury Racing. They took the standard production V6 blocks and engineered them to terrifying extremes. In offshore powerboat racing, a brutal, high-dollar sport where massive fiberglass catamarans pounded through ocean swells at over 100 miles per hour, Mercury became the absolute standard. The crown jewel of this era was the 2.5-liter EFI two-stroke V6. EFI, or electronic fuel injection, a system that sprays fuel into the engine more precisely than a mechanical carburetor, allowed Mercury to squeeze unprecedented power out of a small block. These racing engines were capable of spinning at over 8,000 RPM, producing nearly 300 horsepower from a package that weighed less than 400 pounds. It was a ratio of weight to power that four-stroke automotive engines simply could not touch. This racing pedigree trickled down directly to the consumer. When an American family walked into a marine showroom in Florida, Texas, or Michigan, they saw the same black paint on a 50-horsepower family pontoon motor that they saw on World Championship offshore boats. Mercury was no longer just selling an engine, they were selling an identity. By 1995, the American Marina was essentially a two-stroke monoculture, divided primarily between OMC's white Evinrude and Johnson engines and Mercury's black ones. This ecosystem was incredibly lucrative, not just for the factory in Wisconsin, but for the entire American service network. An outboard empire does not survive on initial engine sales alone. It survives on the aftermarket. A two-stroke outboard required a continuous, specific diet. Boat owners bought millions of gallons of Quicksilver two-stroke oil. They bought proprietary water pump impellers, specific spark plugs, and branded lower unit gear lube. When a motor finally needed an overhaul, a major service process where an engine is taken apart, inspected, and rebuilt to operating standards, the local dealer had a guaranteed stream of labor. The mechanics understood these two-stroke blocks intimately. A seasoned marine technician could stand on a wooden dock, listen to a Mercury V6 idle in the water, and tell exactly which cylinder was running lean just by the pitch of the exhaust and the vibration of the cowling. The system of American recreational boating was built on this absolute trust in cast aluminum, pre-mixed gasoline, and predictable repair cycles. But this entire empire was hiding a fatal flaw, one baked into the very physics of how the engines worked. A traditional carbureted two-stroke engine uses its crankcase to pressurize the incoming air and fuel mixture. Because the intake ports and exhaust ports are open at the exact same time during the piston stroke, a significant portion of the raw, unburned gasoline and oil mixture escapes straight out the exhaust, traveling through the propeller hub and directly into the water. For more than 50 years, the American marine industry had accepted this inefficiency as the unavoidable cost of lightweight horsepower. The blue smoke hovering over a crowded boat ramp on a Saturday morning was just accepted as the smell of summer. The engine was perfectly tuned for what the market had always asked it to do. But the 1990s were ending, and the era of unchecked mechanical freedom was closing. The black motor had conquered the American lake, but in Washington, D.C., a different kind of math was being calculated, one that viewed the smell of two-stroke oil not as a cultural memory, but as a federal violation. The first crack in the American outboard empire did not begin with a catastrophic engine failure on the water, nor did it begin with a sudden shift in consumer demand. It began quietly in the mid-1990s with a printed federal mandate. For decades, the Environmental Protection Agency had focused heavily on cleaning up highway trucks and passenger cars. But in 1996, the EPA turned its attention to the water. The agency announced a sweeping new regulation for marine internal combustion engines. By the year 2006, outboard manufacturers would have to reduce hydrocarbon emissions by a staggering 75%. This was not a minor adjustment. It was an existential threat to the very physics of the traditional two-stroke engine. Because a standard carbureted two-stroke engine pulled its air-fuel mixture through the crankcase while the exhaust port was still open, up to 30% of the raw, unburned gasoline and oil passed straight through the combustion chamber and directly into American lakes and rivers. The raw power, the aggressive throttle response, the lightweight blocks, and the distinctive blue smoke that defined the Mercury brand were suddenly regulatory liabilities. The American marine industry entered a state of sheer panic. Engine companies had less than a decade to reinvent a technology they had spent half a century perfecting. The immediate engineering solution was direct fuel injection, or DFI, a complex fuel system that sprays atomized gasoline directly into the cylinder under extremely high pressure, but only after the piston has closed off the exhaust port. In theory, a DFI two-stroke would keep the lightweight, high RPM power of a traditional outboard while eliminating the unburned fuel emissions. Outboard Marine Corporation, desperate to meet the EPA deadlines and protect its Evinrude and Johnson brands, rushed a DFI technology called FIC to the market. It was an unmitigated disaster. The FIC engines suffered catastrophic powerhead failures, fouled spark plugs, and left thousands of American boaters stranded. OMC dealers, the lifeblood of their service network, were overwhelmed with furious customers and unpaid warranty claims. Mercury Marine was watching its eternal rival self-destruct, but Mercury was standing on the exact same regulatory cliff. To meet the emissions rules, Mercury partnered with an Australian engineering firm, Orbital, to develop its own DFI system, which it branded as the Optimax. The early Mercury Optimax engines, launched in the late 1990s, were mechanical marvels on paper, but they introduced a terrifying level of complexity to the American boat dock. Unlike the old carbureted tower of power, an Optimax required an air compressor, high-pressure fuel pumps, intricate fuel rails, and a sophisticated electronic control module, a computer, to calculate injection timing down to the millisecond. When these early 2.5-liter and 3.0-liter Optimax engines hit the water, the reality of marine environments began to tear them apart. The air compressors, driven by a belt off the top of the engine, began to fail under the sustained high RPMs required by bass boats and offshore center consoles. Spark plugs fouled repeatedly. Fuel injectors clogged if the boater used low-quality marina gas. Suddenly, the local American marine mechanic, a technician who had spent 30 years diagnosing engines with a screwdriver, a timing light, and a sharp ear, was forced to plug a diagnostic laptop into an outboard motor. The entire service culture of the American marina fractured. Older mechanics, frustrated by software codes and complex wiring harnesses, began to retire. Dealership service bays from Florida to Michigan turned into triage centers, filled with black cowlings waiting for replacement compressors and factory software updates. The financial burden of honoring these early Optimax warranties was staggering. Mercury poured millions of dollars into fixing the engines, replacing blown power heads, and redesigning the faulty components. The cost of manufacturing, the cost of warranty labor, and the cost of maintaining dealer trust skyrocketed. In December 2000, that exact same financial pressure broke OMC. Unable to survive the fished warranty claims and a collapsing dealer network, Outboard Marine Corporation filed for bankruptcy. The giant that had ruled the water for generations was gone, eventually bought out of bankruptcy and heavily restructured. Mercury Marine had survived the initial regulatory shock. They had absorbed the massive financial hit, supported their dealers, and eventually engineered the Optimax into a highly reliable, incredibly powerful DFI engine that dominated the base tournament trails. But the victory was hollow. The regulatory rulebook had changed, and it had opened the door to a completely different kind of power. The American boater was already looking past the two-stroke entirely, toward a heavy, quiet, four-stroke future that threatened to erase everything Fond du Lac had built. The shift away from the two-stroke was not just a regulatory mandate, it became a cultural and physical transformation of the American boat dock. As Mercury fought to keep its direct-injected Optimax alive, a deeper threat was arriving from across the Pacific. Japanese manufacturers, led by Yamaha and Honda, had spent the 1990s perfecting large displacement marine four-stroke engines. A four-stroke engine, an engine that completes intake, compression, power, and exhaust strokes across four piston movements, had distinct advantages. Because oil was contained in a sealed crankcase and not mixed with the gasoline, four strokes burned incredibly clean. They were heavily favored by the new environmental regulations. But more importantly for the consumer, they were quiet. For the first time in the history of American recreational boating, a family could idle out of a marina and hold a normal conversation without shouting over the mechanical clatter of a combustion chamber. But four strokes had a massive physical penalty: weight. Because they required complex cylinder heads, the upper part of the engine that helps seal the cylinders and contains the valves, along with heavy camshafts and timing chains. An early 200 horsepower four-stroke could weigh over 150 pounds more than a comparable Mercury two-stroke. When American boaters bolted these new engines to the back of older fiberglass hulls, the boats sat dangerously low in the water. For the American bass fisherman and the offshore tournament racer, this weight penalty was unacceptable. They demanded torque, the twisting force, often felt as the immediate, brutal, pulling strength of an engine that throws a boat onto a plane. A naturally aspirated four-stroke simply could not match the violent, instant acceleration of a two-stroke V6. Mercury Marine found itself trapped between two realities: The Optimax satisfied the fishermen, but still carried the stigma of its early warranty failures, while the market was clearly demanding the quiet, turnkey reliability of a four-stroke. If Mercury did not build a four-stroke that could somehow mimic the aggressive performance of their old engines, they would lose the transoms of American boats entirely. To survive, the company launched a highly secretive $100 million engineering program. In 2004, they unveiled the result, the Mercury Verado. The Verado was an inline six-cylinder four-stroke, but to solve the problem of weight and sluggish acceleration, Mercury added a supercharger, a mechanically driven device that forces more pressurized air into the engine. By forcing more air into the small displacement block, the Verado could generate massive torque right off the idle line. It produced up to 275 horsepower and was engineered to run so quietly that boaters frequently ground the starter gears because they could not hear that the engine was already running. The Verado saved Mercury's dominance, but it permanently altered the American Marine Service network. The new engine was not just a mechanical object, it was a digital system. It introduced true drive-by-wire technology to the outboard market. There were no physical throttle cables stretching from the helm to the engine block. Shifting and acceleration were controlled entirely by digital signals sent to an electronic control module. This level of engineering forced a brutal reckoning inside the American repair shop. For half a century, independent marine mechanics had diagnosed problems by pulling spark plugs, checking compression, and adjusting carburetor jets with a screwdriver. The Verado required a factory-certified diagnostic laptop. A mechanic could no longer tune the engine by ear on a Saturday morning. If a sensor failed, the engine went into a protective limp mode, and the boater was forced to crawl back to the dock at 5 miles per hour. Dealerships were forced to invest thousands of dollars in new diagnostic equipment and mandatory factory training. The mom-and-pop marinas that had sustained the Mercury brand through the 1970s and 1980s often could not afford the transition. The service network consolidated. The relationship between the boater and the engine shifted from mechanical understanding to blind reliance on proprietary software. Back in Fond du Lac, the factory floor underwent its own transformation. The old foundries that had mastered the simple, lightweight aluminum castings of the two-stroke era had to retool for the immense complexity of four-stroke heads, oil sumps, and supercharger housings. Brunswick Corporation leveraged its immense corporate weight, packaging Mercury engines exclusively with the boat brands it owned, like Sea Ray and Boston Whaler, ensuring that the black motors kept their market share as the transition bled the company's capital. Mercury had survived the great outboard shakeout, but survival required cannibalizing its own identity. By the time the final EPA deadlines locked into place, the loud, smoky, high-revving two-strokes that had built the company's reputation were effectively outlawed for mainstream production. The Optimax line was eventually discontinued. The engine still ran. The EPA deadline arrived. The two-stroke line finally stopped. The blue smoke cleared from the marina. The old mechanics retired. The tuning tools sat in parts bins. The software took over the throttle. The black paint remained. The sound that built the empire was gone. The survival of the company was secured, but what remained on the transom was a completely different kind of machine. Mercury Marine did not suffer the fate of OMC. Today, the Brunswick Corporation's marine engine division is not just surviving, it is one of the most profitable and dominant outboard manufacturers on Earth. But the machines that roll off the assembly lines in Fond du Lac, Wisconsin, today share almost nothing with the roaring engines that built the brand, other than the phantom black paint on their cowlings. To understand what Mercury became, you only need to walk down a modern American boat dock. The aggressive, smoking, high-revving two-strokes are gone. In their place are massive four-stroke V8, V10, and even V12 engines. Mercury's flagship modern outboard, the 600-horsepower Verado V12, is a machine of staggering complexity. It features a two-speed automatic transmission and a steerable gear case, meaning the engine block itself remains completely stationary, while only the lower unit turns to steer the boat. It is a technological marvel, but it is also a closed system. A modern Mercury outboard is an extension of a boat's digital network. It is tied to joystick piloting systems, GPS anchoring, and electronic throttles. It is designed to be so quiet that at idle, a boater has to look at the digital tachometer just to know the engine is actually running. The factory in Fond du Lac still pours molten aluminum and still employs thousands of American workers. But the nature of the labor has shifted. The plant relies heavily on robotics, clean room assembly for fuel injection systems, and software engineering. Mercury transitioned from an iron and aluminum foundry into a marine technology company. This was the price of survival. When the Environmental Protection Agency rewrote the rules of the water, Mercury realized that fighting to save the two-stroke was a losing battle. OMC, Board Marine Corporation, tried to save its legacy by rushing flawed two-stroke injection technology, and it died in bankruptcy court. Evinrude eventually bought out of the wreckage, tried to stick with direct-injected two-strokes until 2020, when its parent company abruptly shut the brand down forever. Mercury survived because it was willing to kill the very sound, smell, and mechanical simplicity that made it famous, long before the market could kill the company. But the old American two-stroke outboard did not vanish completely. It just moved off the main dealership floor and into the hands of a fiercely dedicated preservation culture. Across the American South, in the Great Lakes region, and down the coast of Florida, an entire underground economy exists to keep the old black motors running. On enthusiast forums with names like Scream & Fly, amateur racers, bass fishermen, and independent mechanics trade parts, technical advice, and tuning secrets for the legendary 2.5-liter EFI blocks. They hoard genuine quicksilver stators, carburetors, and lower units. At marine swap meets, you can still find dog-eared, oil-stained factory service manuals being passed from one generation of mechanics to the next. This preservation effort is not just blind nostalgia for a louder era. It is a physical argument about the relationship between an American boater and their machine. A modern software-controlled four-stroke outboard is undoubtedly cleaner, more reliable, and vastly more fuel-efficient. But it is also a machine that actively locks the owner out. If a sensor fails 50 miles offshore, the boater cannot fix it. They can only hope the computer's limp mode allows them to idle back to a certified dealership where a technician will plug in a diagnostic laptop. The old Mercury Tower of Power inline sixes and the carbureted Black Max V6 represented an era of mechanical autonomy. An American boater with a basic set of hand tools, a timing light, and a repair manual could pull a boat out of the water on a Friday evening, rebuild the carburetors on the tailgate of a pickup truck, replace the water pump impeller, and have the engine screaming back on the lake by Saturday morning. The blue smoke that hung over the boat ramp was the byproduct of a machine that belonged entirely to the person holding the pull cord or turning the ignition key. When the American marine industry left the two-stroke engine behind, it solved an environmental crisis, but it also severed a cultural connection to repair. The loss of the two-stroke was the loss of a language, a time when you could diagnose a lean cylinder by the pitch of the exhaust, or know that an engine was perfectly tuned just by the smell of the burned oil. Mercury Marine survived the great outboard shakeout by looking at the EPA regulations, looking at the heavy four-strokes coming from Japan, and realizing that the future belonged to silence, software, and complexity. They secured their empire, but they had to leave their original soul in the past. Somewhere in a Midwestern garage, an old Mercury Inline 6 still sits clamped to a wooden engine stand. The phantom black paint scratch, the carburetors dry, waiting for a Saturday morning that no longer sounds the same. See you in the next one.